at different types of mixes of workloads, and they're running continuously. Okay, so there's absolutely no breaks in I/O. So we're just beating the drives. We're not giving them any time to go off and do housekeeping or take care of any back-end flash management. These things are being run effectively full throttle. The other elements that are listed here, by the way, so that's just pure speed. What we also show are some of the economics, okay? So real time with IOs, we've got a dynamic meter that's tracking dollars per IO. Okay, so there's 3 dimensions to this demonstration. There's just sheer performance, which is captured by the speedometer here or the different bar charts down here. Secondarily, we brought in the equivalent dollar per IO, so we'll show you how we derive that. And then also on the back, which I don't have the means to link to here, but we've got power meters that are running off the array that has the 30 drives and a power meter running off the Zeus. And that helps us derive a comparative energy profile as well. So this looks at the economics, okay, from multiple vantage points. And remember, 2 critical currencies in the enterprise, right? So it's how much do I pay for my capital expenditure, what's my power per IO, and then what's my watt per IO? Because IO is what you need out of SSD, right? It's your IO vehicle, it's your IO tool. So if I'm going to pay more for that SSD than I am for my hard drive, it better deliver a disproportionate amount of IO. And so when you look at it from that perspective, you can look at the way in which our customers are then positioning the product to their ultimate end users of the technology. And what we've listed here on the right-hand side is basically the economics of the capital expenditure. Okay, so just looking at your out-of-pocket cost of, say, the 30 Savio drives. So let's say they're going to be $300, maybe they're $200, something in that range. So it's going to range from $6,000, $9,000. We took $9,000 using price points of the $300 price point. So pick your capacity. If it's 146, maybe that's more like $200. If it's 300, maybe it's $300. So that's in that price range. Looking at the chassis that we're using back there, exactly. So that specific demo, we've got 2 different chassis. With all the drives therein. We've got 1 server running the configuration. So those are your total out-of-pocket costs. Now, if you go over to the other side, you can see your out-of-pocket costs just for Zeus. Okay, so certainly you're paying thousands of dollars for this drive. So it's arguably a lot more expensive than a single hard disk drive. But realize how much more I/O you're getting out of this drive. So you have to look at it on a dollar per I/O basis, and you can see that comparatively, you get a better dollar per I/O profile out of SSD. So again, this is just looking at the dollars and I/O. So we haven't even layered in the power and cooling and everything else that goes into that. Okay, so then what we've done to also make sure that we have the storage volume, okay, because there's still some sense of aggregate capacity that you need. We added a couple terabyte SATA drives. So this would look a lot like the way Sun has built their systems. Some SSD and then some nearline SATA type products to deal with the capacity. We don't need any chassis. You don't need all the expensive cabling that goes with that we didn't even classify over there. And you got the same server. So your out-of-pocket expense from day one is already less. So this is a cost savings phenomena from day one, and then it only gets better because then you start to layer on the energy efficiencies and all the other savings that come with it thereafter. So now let's look at the electricity element, which is it's a static number here, but back there on the demo you can see real time what type of wattage we're pulling. But you can see there's a pretty significant multiple. For those that can't read, we're talking about roughly $24 a year with New York electricity rates compared to $1,000 a year with hard disk drives. So big savings from an electricity standpoint. And then we've done, based on this analysis, a 5-year roll-up of, call it your TCO, your total cost of ownership, which starts to layer in the cooling cost associated with cooling the big arrays for drives, and then looking at it down here from a Zeus IOT standpoint, what type of kind of comparative spend you'd have and what your TCO is over time. So it's a pretty significant multiple, and your TCO gets more attractive as you kind of amortize the investment in the technology over time, because your ongoing sustained expenditures are comparatively less when you go to an SSD configuration. So another way of looking at not just dollar per IO, but the energy efficiency as well. Okay, so again, that's just Zeus IOPS. So we still believe that Zeus IOPS is really in a league of its own. there would be really no points in running any other SSD against that product because there's nothing else like it. But what we've done is now we're going to go down into our lower end product line, so our Mach 8 product line, where again people kind of have the impression that maybe an Intel drive or a Samsung drive is kind of comparable and on a similar level there as well. And it's also an area where my belief is that Samsung and Intel said, hey, we got to get a good notebook drive going first. That's where the volume is going to be. And if we can just use SLC and then sell it into servers, wouldn't that be great? Well, yeah, that would be great. But unfortunately, there's a lot required to secure those designs in the servers as well. And we kind of listed that table out that shows that. But let's just look at performance. So Mitch, if you could switch to number 2, I guess that's going to be.
One more point to make regarding the Zeus IOPS with the fiber channel. Fiber channel drives are generally going to be out of usage by 2012 timeline. So as our customers are looking to the future, there's nobody really coming out with an SSD with fiber channel interface. And if anybody was to come out with one, it would take them about 18 months. By the time they get it qualified, they basically have maybe a year left in life. So we believe for the remainder of the life of fiber channel, we will be the only provider of fiber channel in these systems. That's right. Fiber channel against the 30 SAS drives, correct.
And it's a Zeus family, so it could be fiber channel or a SAS, SAS product.
Same performance for both. SAS.
Well, yeah. Okay, so next we're doing the comparative analysis. So same database application running across those 3 different drives. So on your far left is the STEC Mach 8 drive. And you can see we're showing two things here. So the plot up top gives you that kind of real-time dynamic I/O comparison. And we're also giving a readout here across each one. So you got their speedometer effect as well as a digital dial here. And then the Intel drive, and then the Samsung drive. And then we're also doing a plot. So you have kind of your your historical perspective as well. And so it's green for STEC, red for Intel, and blue for Samsung. Okay, and I think it's important to kind of tie back to some of the comments we made earlier about consistent, predictable I/O performance. Okay, so what you'll get out of here is really erratic behavior. Okay, so burst in I/O. Okay, which again does nothing for a server guy. Okay, how do they design around that? I mean, and so you can see the plot over time. I mean, it hits the floor, then it hits the ceiling, and it hits the floor, and it hits the ceiling. And what you see out of the Mach 8 product is just really nice, rock solid, consistent performance throughout the life. And we've been running this analysis for 3 hours this morning, and these are how. And this pattern has not changed. I mean, really, they kind of maybe these two kind of start out similar, and then the Intel behavior just starts going crazy. And so what's happening here is really bad. I wouldn't call it bad. It's just suboptimal firmware for the enterprise. Okay, this drive will probably be great for notebooks, by the way. So don't get me wrong. I'm not saying that this is the world's worst SSD. We're just simply saying that for a server type application, you cannot use this drive, and you certainly get nothing out of this drive. Okay, so again, this is an enterprise workload, and all day long you'll hear folks with products like this saying, "Oh yeah, I can address server applications as well," and sure enough, I can show performance like this. Well, this is reality. Okay, so this is we're throwing mixed workloads at the drives to see what the real I/O performance is, and so it's not 512 by my fastest read I/O is 30 some odd thousand. Who cares, right? I mean, this is what matters, okay? It's got to be at larger transfers, so 8K transfers, 4K and 8K are the prevalent transfer sizes, not 512, because at 512 is easy. You get your fastest, and so everyone specs their drives. This product will, Zeus IOPS, you can see we got the dial even in the 3,000 range, capped at 3,000. If I ran at 512, I could show you numbers that are well over 10,000, but again, that's meaningless, right? Because that's not at 8K transfers, okay? So all these different systems are going to need 4K and 8K transfers. So you need to look at it under that type of environment, those transfer sizes with a mixed workload, okay? It's not going to be all reads. It's not going to be all writes. If it is, those are very specialized applications. There's going to be some type of mix. And so this kind of helps explain why I think in many ways there are no server deployments today with a universal storage solution, so a hard drive replacement. I mean, sure, you can take one of these drives and use it for boot, because it's going to have fast boot. It's going to have fast reads, particularly if it's bursty reads. You only need a little bit of speed. Sure, that's an improvement of a hard disk drive. But to use it as a hard drive replacement, the performance profile better be a lot more like this green one than either of the others.
Key to point out, by the way, that when Intel is talking about them playing in the enterprise, they're talking about enterprise laptops, not enterprise storage or servers. And the type of usage that you can see and the type of performance that they have, it actually matches very well with a user on a laptop, because you use an application, and then after you use it, you have a lot of idle time, and in that idle time, they're doing a lot of the background cleanup and background operations. And what you see in real time in a server is those background operations are really becoming foreground operations. So literally, the interface is no longer being supported with getting reads or writes, and that's why the performance drops off. So the product may be a perfect product for a laptop, but it has no room in the server environment. And that is exactly what we hear from our customers when they evaluate the Intel product. Direct quote out of the CTO of Hitachi was, the product was fast, but unstable and unreliable. So that's why all of our customers, when they look at this, comparing it to our technology, they prefer our technology to be incorporated across the board than a point product that's an Intel or Samsung have done.
Okay. So with that, actually, that concludes the formal portion of the presentation, and we'll open it up, Manoush, for Q&A.
Question, please.
Let's go.
Rich.
Thanks. Good morning. Just a couple technical questions, Mark. If you had to break down the reliability that you get on the Zeus, how much do you think is attributed to the extra capacity you're not using in the system, to kind of backfill over time versus the controller technology itself? Is that the right way of looking at it?
So the controller technology obviously gives you reliability from its full data path protection and such. With regards to the over-provisioning that we do, that gives you better endurance over time. That means we talked about this write amplification. Your write amplification goes up as the percentage of the usage of the drive compared to the total available amount of NAND flash goes up. So if you end up, for example, using 90% of a drive for the capacity of the drive and having 100%, you get a write amplification of somewhere around 10. That means for every 1 gigabyte you write, actually the drive will end up having to write 10 gigabytes on the drive. So the lower that amount, the longer the life of the product from a flash endurance perspective. But it has absolutely nothing to do with regards to other reliability measures with regards to read writes. We do a lot of things in the production of our products, burn-in of our products, to make sure we get rid of all early life failures with regards to NAND flash block level failures. And all of those things are basically marked bad, so our users don't end up actually using them. So when the drive goes out, it actually demonstrates very well. We've had drives running now for like 6,000 hours in systems without even read errors on them. And this is unheard of in a disk drive world.
And then in the Sun system, can you just talk about what was done to make it just for writes on the Zeus? Was that something that you tailored for them, or is that something that Sun has in their own software or firmware?
No, generally when these systems are designed, storage systems, they have a write cache, and those write cache is generally a DRAM that then, because it's DRAM and the power could go away and get lost, they have DRAM with power backup, so sometimes they have to power back up the whole system. Sometimes they have to get battery backup systems to just power up the DRAM itself. In that application, they found out that it was easier for them to write that data into one of our SSDs, because our SSD has the write cache with power backup on it, and they get a very, very low latency on write. So in normal disk drives, you basically have to commit the data into a non-volatile storage. So if it's on a disk drive, it has to be written to the media itself before you can acknowledge it back to the host. In our competitors' SSDs, they have to actually write it to the flash before they can go back to the host and say, we're done. In our case, As soon as the write happens into our buffer, which is our DRAM, we actually go back and say, we're done writing, because that DRAM is power backed up. So even if the power is lost, we will then copy that data into the flash, and you have no data loss whatsoever. So this lower latency of write was able, in the case of Sun, they were able to basically eliminate their DRAM with power backup, which was, by the way, limited to only 1 gigabyte. They could not put 2 or 4 or 8, and they needed a lot more than that, because what happens is there's a ratio of this write cache to the amount of storage you have. So when you go into a terabyte of storage, maybe 1 gigabyte was enough. But if you wanted to do 15 terabytes, all of a sudden you needed a much bigger DRAM that they didn't have available. So with one of our drives, they were able to achieve 2 things. Get rid of all of the complexities that was associated with the DRAM and the power backup, but also get rid of the limitation that they had with regards to this hard ceiling of 1 gigabyte.
Okay, and then just lastly, from a finance perspective, what type of revenue level do you think you need to hit this 40% gross margin and 20% operating margin long-term target, regardless of whatever year we're talking about?
Yeah, over $100 million a quarter. Fourth row here.
Thank you. When you laid out your business model here, which is be vertically integrated through the controller, the system, and the manufacturing, I'm curious if growing this business longer term, if you can really maintain the core competencies in those, particularly when you're up against companies like Intel and Samsung, and is it also a good use of all your capital to be so broadly focused at this point?
As you can see from those demonstrations, we're doing quite well against those 2 guys anyways. But I think some of the things that Mark and Pat said, this is a very niche type of product. It goes to a very high level of technology. And usually the big guys are not so good at it because they have to sit down for years, months, and work this out with their customers. One of the things that is really the big advantage for us is the fact that we actually do have all of these core competencies in-house, building the controller, and then building the full drive, designing it in-house, testing it, and shipping it out helps us out a lot because we learn a lot across all of these things that we're doing. So getting feedback from customers, knowing exactly where the failures are or potential failures are, and then going back to our engineers, redesigning our firmware or hardware to add those sort of questions, that's the biggest thing for us. So core competency, absolutely. And in terms of capital, it is extremely important to do our own manufacturing at this point because these things, again, are things that need to be extensively tested. They have to be meticulously designed and manufactured. And we need to know exactly what's wrong with the system when it comes back to us.
Thanks, Mark.
We'll come to you now after this. Yes.
Yeah, thank you. I wanted to build on a question earlier about the gross margin targets. You know, the $100 million in revenue looks like a pretty significant ramp from here. What time frame are you expecting to get there? And then also, what is that underlying assumption? What are the underlying assumptions around the mix of product and the gross margin structures of that mix?
So 100, I'm not going to give a timeline because you guys are going to build a model based on it. But $100 million is actually not that big of a ramp from where we are today. I mean, we are saying over $70 million this quarter. So and these are just sample quantities of these drives that we are shipping at this point. I think once all of the big customers that we've mentioned here start producing their end product with using our SSDs, I think we'll get to our $100 million. But the $100 million assumption is that good portion of our revenue comes from the very high-end Zeus IOPS and market IOPS type of drives. Because market IOPS will have about a 35% gross margin associated with it. Zeus IOPS will have about a 55% gross margin associated with it. The lower-end SSDs will have about 20% associated with them. So they're not helping out on the high end. And our regular flash business that we do today with the telecom companies are in the 40% range anyway. So that's in the middle of the road. So Our goal is to just grow our Zeus IOPS business, and I think that's happening as we speak.
Very helpful. And then final question, I don't think you've talked a lot about the potential move from FPGA usage to ASICs or vice versa. I forget which one it is. But can you help me understand when that possibly materializes and what that also means to the model is that meaningful from a margin perspective?
Well, going to an ASIC means that the number of units that you're planning to ship are a lot higher than we're doing today on FPGA models. Because building an ASIC by itself, Pat, this gentleman has been putting his hand up. Doing an ASIC costs us a ton of money, over $10 million to do the next generation ASIC. We're planning on it right now, and probably by the end of next year, we'll have an ASIC out that will, especially on the SaaS side of things, will address the market. We think that SaaS product that we have just announced today will have a huge market. The quantities are going to be very large, and as a result, I think an ASIC will definitely help with that. In terms of margin, I don't think it's going to change the margin structure. All it is going to do is keep our margins the same, keep competition out, because competition is not going to be able to come up with an ASIC right away. You need to build these products based on FPGA, test them out for a year, make sure all the kinks are out of them before you turn into an ASIC. So that's about a year away, and hopefully we can keep the same 50% margin plus on our Zeus IOPS product lines and keep the competition out that way. Yes.
Hopefully, actually, one more point. Hopefully, it's clear that FPGA-based products are a fraction of our mix today. Okay, so the preponderance of our products we ship are all built around proprietary ASICs from STEC. This product over here, that's an ASIC-based SSD. So I don't view that as like a monumental change, capital commitment, or anything like that.
I think he's talking about FPGA and Zeus IOPS product lines.
And again, as a matter of fact, for the remainder of the life of the Zeus IOPS with fiber channel, it really doesn't make sense for it to even go into ASIC. So the only reason that we're going to do a ASIC for our SaaS product line is because that product will be used on high-end storage and servers where we anticipate the volumes to be as such that it would require a lower cost base, and that's why we're doing it. And additionally is to achieve some of the higher speeds, like the current generation of the SAS that we've just introduced is 3 gig SAS, and the next ASIC will be a 6 gig SAS. In order to achieve those, we need to be in ASIC technology, and that's another reason that we're doing it.
Go ahead.
Thanks. Gary Schway with Oppenheimer. You stressed the importance of vertically integrating at a system level. I'm just wondering, A, how intertwined is your development activity with the actual design of the media itself, the NAND flash? And B, do you foresee a point where you actually need to be vertically integrated with NAND flash design? And if you think in the future that will become, a necessary criteria, or if you think it'll be a handicap to your development efforts in the future, especially with reliability of the media itself kind of degrading with, as you jam more bits per cell for lower cost.
We're actually finding it that most of the flash manufacturers want to work with us very closely to create better endurance flash, and we currently have a program that we're working with mnemonics on enhancing the NAND performance. And there's so much capacity in NAND available in the market that everybody's trying to find new homes, new applications for NAND. So we don't foresee ever needing to be vertically integrated with the NAND supply. As a matter of fact, at least for the next 3 years, we think that there's going to be an oversupply of NAND, and when you can buy it cheaper than building it, why invest in it?
Yeah, I don't think that in the past 19 years, there has been more than a couple of years in intervals where people who actually made the actual media, if it was DRAM or flash, they were profitable more than we were. So I don't think that is such a great business model, knowing that everybody wants to have a big market share and the building based on that versus demand. So I don't think that we'll, at this point, we're foreseeing ever partnering up with a flash manufacturer to own part of the fab lines. But we've got a partner in Samsung who we've been working with now for the basically whole life of our company, We've got a great relationship with them. They have built the SLC chips in a manner where it works perfectly in our Zeus IOPS and the very high-end systems. And we're constantly in talks with them and discussions with them, and trying to make sure that their SLC flash is a good flash that could be worked in this area. And frankly, by going through us, they're getting 100% of the whole enterprise market out there. So in order for them to address that market, if they're ever interested in getting to that market, they have to make sure that their devices work in our systems.
Pat, just a
Yeah,
question
go ahead.
for you on, you mentioned you're in discussions with a whole host of new potential enterprise customers, sole source type of customers. You've got this new SaaS product, you've got this new product coming next year. And, third on your list of things that you're trying to improve for customers was cost reduction, and I was kind of hoping you would talk about, I guess Malaysia is part of that, but when you're in negotiations, what's the balance here with regard to you being really the only player right now, and what are you willing to give away in terms of price, either to seed the market or become sole source or to win a contract?
Actually, we're not doing any sort of concessions on our gross profit margins. Those are staying steady. You've seen it. I mean, even when we went to this PCIe type of thing and we shipped in large quantities, our margins stayed pretty similar to what they were before. And so that is going to be a constant. If there's going to be any sort of a price discussion, it's going to be because we're able to cut our own costs down, or we're able to talk to Samsung and bring their costs down to a point where we're able to give a better price to our customers. And everybody's working in concert. This is not a one-man type of a show. So when we go to Samsung and talk to them and say, hey, the price of flash should be at this level for us to be able to ship this many units during this quarter, they usually go back to their management and they come back and they give us a price that we can hit those sort of numbers. And we are seeing that this is a slow ramp, going from $12 million 2007 to $50 million. From our point of view, it's still a pretty slow ramp for this thing. We needed to get to $1 billion type of markets fast. We got to get Samsung to bring their price down, and we have to shrink our costs down to be able to come up to about $10 a gig type of a pricing for these type of a high-end enterprise storage media.
So with your memory pricing coming down, continuing to come down fairly dramatically, and you're about to undertake this significant ramp in Malaysia, the gross margin issue really for the foreseeable future is not much of a challenge for you.
I don't think so. Malaysia plant actually, once we're able to, at the end of first quarter of this coming year, we'll be completely out of the U.S. in terms of production, and all of our production will be done in Malaysia. At that point, I think we're going to at least get about $1 million per quarter savings just on the operations and manufacturing costs, which ends up to be about 1.5 cents or so per quarter addition. So that's a pretty good number, and it's going to add about 2% in our gross margins because of going to Malaysia. Plus, obviously, about the taxes. Our taxes should be coming down pretty fast once we're producing and shipping out of Malaysia in a full-time manner. Go ahead, Matt.
Thank you. Can you help us size the market opportunity for Zeus with fiber channel interface?
Well, I can't give you a size because, again, that's going to make it say its way into different models. But I can tell you that all of the guys who are shipping fiber channel today, they're staying with us. They're not qualifying anybody else. There's no one else designing a fiber channel drive today. So we think that at least for the next 3 years, that most of our customers are still planning to ship a fiber channel type of a system. They're going to be using our product.
And the qualifications that all the major accounts should be completed by the end of Q1 09. And those things should be in production, for the second half of that year.
So to date, you focused on hard disk drive replacement strategy. We know that in the past, IBM announced some system performance records using a solution that plugs in the PCIe Are you guys looking at those types of products as well?
Yeah, yeah. It's so this is so Dave's referencing the prospects of using a bus attach SSD. So that could be PCIe, it could be InfiniBand, it could be something like that. It's going to be, by the way, very interesting to see this announcement, what they ultimately use when they productize. It's going to be something fundamentally different, and it's going to be STC content. So, good news about that is even though there may be some interesting benchmarks being achieved based on creating really fast bandwidth with a bus attached SSD, at the end of the day, the enterprise loves the infrastructure that we have around standard trusted interfaces, right? You may have saw in some of Sun's comments, like, listen, the technology's there, the speed's there, and it's an interface I know, it works, it kind of addresses about 40% of the qualification effort that's already behind you because it's a standard known interface. And remember, all these chassis are being built with slots and interfaces that work with hard drives, and they want interchangeability. So there's just so much the infrastructure that has been invested in and built around traditional storage interfaces and connectivity that is forever going to be the bulk of SSD business. Like that is definitely the case. Now, there are interesting applications for bus attached SSD, and definitely expect stuff from us there when the time's right. So, and we think those are much more niche applications. It's application acceleration for servers. And there's also some other even more niche-y things that we're seeing out there as well. So basically, we believe that everything we've done in Zeus translates over into that very effectively. So Mark's team is basically working on that stuff right now. If you want to,
Yeah, we have unique applications. It's not I would